The other day I said that I believe the big idea of Algebra 1 is really focusing on those linear equations and how to solve those. So today we're going to hit that lesson hard and kind of review that big idea of Algebra 1 with solving linear equations. We're going to begin with more basic equations, and kind of every step along the way we're going to bring something else into it and refresh all those ideas.
I got the wrong binder. Can I go switch it?
An equation is where we take those expressions that we talked about yesterday that have numbers and variables and grouping symbols and operations, and we put in equals with it. Once an equals comes into the problem, it is now called an equation instead of an expression. A linear equation means that whatever a variable is, x or y or n, it is only to the first power. So we don't see any x squareds in these. They're just plain x's. They might be multiplied by things, they might have things added to them, but they don't have any exponents on them. A solution is something that makes an equation true. There might be one, there might be more than one, there might be none, but a solution is anything that works. Any number that when I plug into the equation, it makes it true. Equivalent equations would have the exact same solutions. There are a few different things that we are allowed to do to our equations to solve them. The first thing is we are allowed to add anything we want to both sides of an equation. Really, truly, anything we want. So like you could just take an equation and add 72 to both sides. It might not get you any closer to the right answer, but you're allowed to do it, as long as you do it to both sides. You can subtract on both sides. You can multiply on both sides, except by 0, because multiplying by 0, that just makes everything go away. But otherwise, you can multiply by whatever you want on both sides, and you can divide by whatever you want on both sides except 0, because dividing by 0 is like the biggest no-no in math. But I could take an equation, and I can multiply the whole thing by 5 if I wanted to. Might not help, but it's allowed. I could do it, and it wouldn't make anything wrong. It just wouldn't necessarily be helpful. So to solve a linear equation, our first step is to get the variable part alone. So this part that has the variable in it, I'm going to get that part alone. So I'm going to do that by undoing the plus 9. The opposite of adding 9 is subtracting 9. So I'm going to subtract 9 from both sides. It gives me 3/7 x equals 6. And then my next step is get the letter itself alone. To get that x alone, I need to undo the 3/7. 3/7 is being multiplied, so I could divide both sides by 3/7. How do I divide by a fraction? Multiply by the reciprocal. So I'm going to flip that over, make it a 7/3. Multiply by that. And that gives me 14. 6 times 7 is 42. Divided by 3 is 14. You can always know if an answer to an equation is right. That's something I love about algebra. You never have to turn in a wrong answer. You might not necessarily be able to find the right answer, but you can at least know if your answer is right or wrong by just taking it back to the beginning and plugging it in. So if you take that 14 back up to the beginning and you put it in for x, plug it in, you should end up with 15 equals 15. And that will confirm that you found the right answer. I'm not going to make you check your answers. I think it's a good thing to do. I understand why you might not want to take the time to do that on every homework problem, but especially when it rolls around to a test, it's not a bad idea to know that you're handing in the right answers on a test. Because then if you see that it doesn't work and you end up with something like 13 equals 15, you know there's a mistake in there somewhere that you can start looking for. Questions? Go ahead and try this one. Okay, so first thing I'm going to do is get the variable part alone. I'm going to do that by subtracting 8. Undo what's being done. So adding 8, we undo by subtracting 8. And that leaves just an 8 on the other side. Then I want to get the variable itself alone. It's being multiplied by 2/9, so I'm going to divide by 2/9. Dividing by 2/9 is the same thing as multiplying by 9/2. And that gives 36. Questions? Alright, so I said in every problem we're going to kind of step it up a little bit. So in this problem we now have variables on both sides. There are a lot of things you could do first here. In fact, there's like 4 different things that would all make sense to do first. I have a preference, but it's just me and it's my personal preference, so if you do it differently, that's okay. It's not wrong. The thing I like to do first is get all my variables together. And the way I like to do that is in a way that will keep them positive. So what I would choose to do first here is subtract 5n from both sides. You could choose to do something else first, like subtract 11 from both sides, or add 9 to both sides, or subtract 7n from both sides. Those are all good things to do that are heading you towards the right answer, but I just like to get my variables together first, and I like to try to keep them positive because I lose the little negatives. But that's a preference. So that leaves me with 11, 2n minus 9. Now this starts to look a lot like the last problem. So I'm going to get the variable part alone by adding 9. And I'm going to get the variable itself alone by dividing by 2. And again, once you think you've reached a final answer, you can always check that by taking it back to the beginning and plugging it in. And if I would do that in this problem, I would get 50 plus 11, which is 61, should be equal to 70 minus 9, which is 61. So I know my answer is right because it resulted in truth. Okay. Questions? Go ahead and try this one. My choice for my first step is subtracting 4n from both sides. You may have done something else first, and that's totally fine. It could still be a step in the right direction to get an answer. Lots of other things you could do. I'm going to choose to get all my n's together and try to keep them positive. Then I'm going to add 3 to both sides. And then I'm going to divide by 8. And that gives me a result of 3. And I can take that back to the beginning and plug it in and check it and make sure that it does result in a true statement. And it should in this case. Questions? Okay, so every problem, we're going to step it up a notch. So in this one, now we've got some parentheses. So our first step is get rid of these parentheses. How do we do that? Distribute on through. Multiply what's out front by everything inside the parentheses. That gives me 12x minus 20. You stop when you reach a closed parenthesis. So I don't just keep on going and multiply everything in the whole problem by the 4. We just pass it through its group. Then on the other side, be very careful. We are not passing out a 2. We are passing out a negative 2. Negatives attach themselves to the number that follows them. So that gives me a positive 2x minus 16, and then stop passing it out. It doesn't pass out to everything. It only passes out to the group, so that negative 6x just tags along. My next step is to combine like terms where possible. So on the right-hand side of this equation, there are 2 different terms that have x's. So I can put those together. Say I have negative 4 x's on that side altogether. Now this problem looks a lot like the last one. So there are several things you could do. I'm going to choose to add 4x. Then I'm going to add 20. And then I'm going to divide by 16. And I ran out of room to do that, but divide by 16 here, and that gives me x is 4 over 16, which is the same thing as 1/4 or 0.25. Now my preferences for the way that you give an answer, I prefer fractions in their reduced form. So to me, my best answer to this problem is 1/4. 0.25 is also to me totally acceptable in this problem because it's nice and clean. I didn't have to cut it off or round it. It's not repeating. So if you get a nice clean decimal, that's okay as well. If it's a messier decimal, like something you would need to round or cut off, or if it's repeating, just leave it as its fraction form, but give it in its most reduced form. Questions?
Can you leave that up for a second?
Yep. Go ahead and start on the next problem, and I'll leave this up here for a minute. I know you probably haven't had enough time to totally finish it out yet, but just looking at the clock, we lost about 10 minutes at the beginning of class with the assembly, so I want to make sure we get through each type of example. So I'm just going to go ahead and pick this up and work through this with you now.
Oh.
Okay, so the first thing I'm going to do in this one, like the last problem, is distribute. So I get 5x minus 10 and pass out the negative 4 gives negative 8x minus 28, and then the plus x tags along. Combine x's together if they are on the same side to give negative 7x. Then I start moving stuff side to side. So I'm going to choose to add 7x. You may have done something else, and that's okay. Then I'm going to add 10. And then I'm going to divide by 12. It doesn't go in evenly, so my preference is the reduced fraction. They both reduce by 6 to leave negative 3/2. But that is a nice clean decimal, so negative 1.5 would be an acceptable answer as well. Questions? In our last type of linear equation today that we're going to look at, we're going to have fractions to start out. Most students, I find, don't like fractions. Some do, but most don't. And so you could just work this problem through with the fractions and begin by like subtracting 1/3 x from both sides. You have an x minus 1/3 x gives you 2/3 x. Sometimes you're going to have to find common denominators, and that can get a little bit messy for students. So what I like to do is get rid of the fractions in the problem. And the way we can get rid of the fractions in the problem is by multiplying the entire equation by what is known as a least common denominator, which is the smallest thing that all the denominators evenly divide into. So it should be bigger than the denominators, and they should all go into it evenly. So in this problem, I'm going to multiply everything by 12, because 3, 4, and 6 all divide into 12. And it's legal to multiply everything by 12 because I'm doing both sides of the equation. So remember, one of our properties said you can do whatever you want, add, subtract, multiply, divide, as long as you do it to both sides. So I can multiply everything by 12 if I want to. So when I multiply 1/3 times 12, that gives me 4. When I multiply 1/4 times 12, that gives me 3. Everything, so even if it's not a fraction, if I multiply x by 12, it gives me 12x. If I multiply 1/6 by 12, it gives me 2. Now I don't have any fractions anymore, and this problem looks exactly like a problem that we've already solved. I'm going to go and subtract 4x. You might choose to do something else, but that's what I'm going to do. Then I'm going to add 2. And then I'm going to divide by 8. That doesn't reduce and it doesn't really go in very nicely, so I'm just going to leave it at 5/8. So since that's a different denominator than any of the original denominators, that means at some point if we were solving this through, we would have had to get some common denominators and do some reducing and stuff. So I find it's easiest to just get rid of all the denominators as a start. Questions? I'm going to just work this next one through with you. What would we multiply everything by here? What do 3, 5, and 10 all divide into? 30. 30 is the smallest thing they all divide into. They also all go into like 60 or 150. Those are all okay things to do as well. You're just going to have bigger numbers to work with as you work your way through. But you would get the same answer in the end. If you can find the smallest thing, that'll keep your number smaller as you work your way through. 2/3 of 30 is 20. 1/5 times 30 is 6. Everything, even if it's not a fraction, so that 2x times 30 is 60x. It is a lot of x's. And then we get minus 9. 3/10 of 30 is 9. So these numbers are already kind of big, so if you chose something even bigger than 30, it might work, but you're going to have some really big numbers to work with. I'm going to subtract 20x from both sides. Add 9 to both sides. And divide by 40. This does reduce. 15 and 40 both reduce by 5 to leave 3/8.
How'd you get the -9 again?
-3/10 times 30. So multiply the 3 and the 30 gives 90, and divide by the 10 gives 9. Other questions? Word problem. We have a real estate broker making $18,000 a year. Even if she doesn't sell a house, she might not have a job next year, but she at least makes that this year. Then she gets 4% commission on her sales. How much does she need to sell if she wants to earn $55,000 for the year? That's her goal salary to meet her needs for her bills and whatnot. So she's going to make $18,000 no matter what. Then she gets to add to that 4%. When we work with percents, we need to turn them into decimals. So 0.04 times her sales, X. We don't know how much she's going to sell. That's what we want to find out, is how much does she need to sell. So that's what will make up her total salary, and she wants that to equal out to be at least $55,000. We could then solve that equation from there by subtracting 18,000 from both sides and dividing by 0.04. A little bit short on time. Does anybody have questions on how we set it up? And the solving is the same as previous examples. I really want to be able to spend time on this next problem because you will have a problem very similar to this on your assignment, and it's usually one students have questions on. have a 3x5 photo that you want to enlarge, mat, and frame. So I've got a picture that is currently 3x5. I'm going to put a mat and a frame around this thing. I want the width of the mat to be 2 inches on all sides. So I'm going to have 2 going all the way around for this mat around my picture. But I'm going to enlarge this picture. So right now it's 3x5, but I want to enlarge it. When you enlarge a picture, you want to do so with a nice scale that's going to let people keep on looking like they look and not start to look really tall or really wide. Okay? So we want to enlarge it both by the same value of multiplying by x. So right now the picture is 3x by 5x, or right now it's 3 by 5. In the end, we want it to be 3x by 5x, where x is how much we're enlarging by. In the end, I want the perimeter of the frames to be 44 inches around. Perimeter is adding up around all the sides. So what we need to know are how long are all of these sides. Down here, I've got the 3x of the picture plus 2 mat on each side is 4. Over here, I've got a 5x of picture plus 2 of mat above and below. For perimeter, we want to add those all up. So I got a 3x plus 4 on the bottom, a 5x plus 4 on the side, oops, not equals, plus 3x plus 4 on the top, and another 5x plus 4 on the other side, and I want that all to add up to 44. Got a lot of like terms to combine and solve on through, but then this is like previous problems. The problem in your homework is about a pool. The pool is already its size. So the 3x and the 5x will just be numbers. They won't have the x's in there if we relate it to this problem. But in that problem, we're trying to figure out how big of a walkway can we do. So in the problem that you'll have on your assignment, your x's are going to be where the 2's are, trying to figure out how big our walkway can be, and then you'll be given dimensions of the pool. Okay? Questions? The last thing we need to talk about quickly today is some weird things that happen in an equation. When I distribute through in this problem, I end up with 5x minus 20 is 5x plus 12. When I subtract 5x from both sides, I get negative 20 is 12. Is negative 20 12? No. But I don't think I did anything wrong. So I ended up with a statement that is not truth. What that means is there is nothing that will work for an x to make this equation true. This problem has no solution. If you end up with your variable disappearing and an untrue statement of numbers, there is no solution to that problem. If you end up with your variable disappearing and an absolutely true statement, something like 2 equals 2, all real numbers work. Okay? If it's a false statement, there's no answer that works. If it's a true statement, any answer will work. Have a good weekend.